Okay, this presentation is on regular expressions, and I'm going to keep this presentation just on the topic of regular expressions because this can apply in Unix, Perl, Python, anything that says they use regular expressions or regex. And then later I'll come back and make a video specifically on Python and how you use regular expressions in Python. So it's kind of hard to explain exactly what a regular expression is, but the definition I usually give people is a regular expression is a way to define all the members of a set without having to explicitly list all the members of the sets. So it's a symbolic way to refer to strings. And I will give you an example. So if you have the regular expression A, B, star, C, if you kind of read it out longhand, it may help you. But a string is going to match this regular expression if it contains an A followed by 0 or more B's followed by a C. So AC will match this, ABC, ABBC, etc. So that's what I mean by defining a match without having to tell every possible string. Now, why do we care about regular expressions? Well, some common uses are to take a string, maybe it's input from the user, but take a string and break it apart based upon a pattern, and we'll see some examples of these in a bit. To validate input or format of strings that you read, for example, from the file or from the user, you can basically say, I told the user to put it in this format. Here's a regular expression that matches that format. Does this string match this regular expression? And then if it does, great, continue on. If not, maybe you explain to the user what you're expecting and ask them to input the data again. And then another common thing is we can break the string apart, but we can also extract a substring or substrings out of that based upon the regular expression and something that we'll talk about called back references. So I'm going to give you a bunch of examples. Kind of the easiest or most fundamental is just a period. And if you have a period in a regular expression, this means there is one character here and only one, and I really don't care what character it is, so this will match all characters with the exception of a new line character. So there just has to be some character at this location. Another thing we have, this is an example of an anchor that we'll talk about in a moment, is \b. And basically what \b means is a word boundary. So a word boundary is something that might appear before and or after a word. So these boundaries can be things like the beginning of the string, the end of the string, white space, which if you haven't heard that term before, is anything, any character or characters that you have that you see the effect of, but you don't actually see the character. So if you have a string like A space 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 B, those three spaces would be referred to as white space. We know they're there because the A and B are spaced apart, but we don't actually see the character. We see the effect of the character or characters. And then punctuation. So you might have a word at an end of a sentence, and there might be a question mark or an exclamation point or anything that might be considered punctuation. So an example might be \b Fred \b, and this would match the name Fred. However, it would not match Frederick because that R that appears after Fred is not a word boundary. Another thing we need to be familiar with is what's called lazy matching and greeting matching. So lazy matching is you just look for the bare minimum, the first shortest occurrence of a string that matches your regular expression. Kind of the opposite of that is greedy matching, and what you're going to do is you're going to find the longest match. And I know that I'm going to talk about Python, but in Perl, the default originally was lazy matching because you just wanted to know if it was true or false and make your program as efficient as possible. But over time, they determined that in most situations, especially if you're extracting strings, you really wanted the longest match. So Perl changed their default regular expression to greedy matching, and then Python, when it was created, which a lot of things in Python are based on Perl, they just started out with greedy matching because that's what most people want. Now, if you have a situation where you really want to do lazy matching, you can do that. And the way you do that is by putting a question mark after quantifiers. Quantifiers are things that tell how many. And we'll see a list of a bunch of the quantifiers that regular expressions have. But the one thing you've already seen is the asterisk. Notice it was A, B star, C, and I said it was an A followed by 0 or more B's. So the quantifier quantifies the thing before it and tells how many. So example is, let's assume we have this string with a bunch of A's and B's and C's in it, and we want to do A dot star C. So it needs to start with an A, and then I can have 0 or more characters and a C. So the longest string, because this defaults to greedy matching, is going to be AAA, BBB, CCC, BBB, CCC. So most of the string. It doesn't have the last AAA. Now, if I put a question mark after that asterisk, I want the shortest match, which is going to be AAA, BBB, C. So there's an example of greedy matching and lazy matching. Now, I mentioned back references before, and basically in the case of back references, adding a set of parentheses around part of the regular expression is basically ignored and doesn't change the matching part of this. But what happens is after a match occurs, what's inside those sets of parentheses is remembered. And you can have multiple sets of parentheses within a regular expression. So don't want to talk a lot about this because, like I said, I was trying to keep this as general as possible, not tied to any particular language. But the mechanism varies for retrieving these matches. For years I used and taught Perl, and Perl has special variables. The first set of parentheses would be in a special variable $1. Whatever was in the second set of parentheses would be in $2, etc. Now, in the case of Python, you're going to have a match object, and you're going to call a method on that match object to retrieve the messages. The matches. They'll be referred to as 1, 2, 3, etc. as well, but it doesn't automatically put them in individual variables like Perl does. Now, when I talked about quantifiers, I say quantifiers quantify whatever is in front of it. We've seen examples where there are single characters or dot, which represents a single character. But what I want to talk about now is character classes. And basically what a character class is a list of characters in square brackets. So an example of this is if I wanted to say, at this particular location in my string, I need to have a vowel. So what I can do is I can have a character class, A, E, I, O, U, And basically what that's saying is at this location, I can have an A, an E, an I, an O, or a U. So I can have one of these at this location. If I want to specify a particular location has to be a digit, I can use 0-9. So the thing to note here is that I can give ranges within my character classes. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I wanted all the alphabet characters, knowing that a lot of languages and systems are case sensitive, I might have this character class, the 26 characters from capital A to capital Z, or one of the 26 characters from lowercase a to lowercase z. So that would be alphabetic characters. Another thing we do that can be somewhat related to character classes is we can have these things called meta characters. So they represent something. So we've already seen period, which represents a single character at this location. That is a meta character. Another meta character is \d, which represents any digit. So that would be the same as putting the character class 0-9, kind of a shorthand, if you will. \w means it's a word character, and a word character is considered A through Z, either uppercase or lowercase, any digit, or an underscore. So that's the character class there at the end that would represent a word character. \s is white space. The character class we have here is space, new line character, return, tab, and form feed. So those are the things that are considered white space. Now, I didn't really know what to call this next part, so I called it meta character opposites. So if we capitalize the letter in the meta character, it basically means the opposite. So \d would be any non-digit. So at this location I can have anything I want or anything except a digit. Likewise, \W is a non-word character, and \s is a non-white space character. So I can't have white space at this particular location. So those are some of the really common meta characters. Let's look at some examples of meta characters, and I'm also going to throw in some examples of back references as well. So the first example looks like this. So if we look at that first part of this, \s plus means one or more characters of non-white space. And then I'm going to remember that match. Here I have white space, so there can be one or more occurrences of white space. I don't care about remembering that. And then finally I'm going to have more not white space, and I'm going to remember that. So I'm remembering things on each side of white space, and basically, quote in English, what this is doing is it's going to find and remember the first two words in a string. Another example might be something like this. I have time space, so that's part of my regular expression, so that string has to appear. And then I have two characters, two characters, two characters, and those sets of two characters I'm going to remember. And as you might guess from the string time, basically what I'm trying to do here is find and remember hours, minutes, and seconds. So that's examples of meta characters and back references. Another thing I mentioned a moment ago was anchors, and we saw that when we were talking about word boundary, \b. Other way to represent anchors is a caret refers to the beginning of the string. A dollar refers to the end of the string. So some examples of that is if I have $A, that basically means as long as this string starts with a lowercase a, I have a match. If I use two anchors, this means I have the start of the line followed by an A, followed by a B, followed by a C, followed by end of string. So that basically means the only string that will match this is the string that is exactly ABC. Now you have a space before it, space after it, doesn't match because we have the anchors there. I talked about quantifiers in this presentation. I put this under repetition. We've already seen star, which means 0 or more occurrences. We talked about plus in an example, which means 1 or more occurrences of whatever is in front of me. We have a question, which in regular expressions is 0 or 1 occurrences of a particular character. Now at the Unix command line, that's going to mean 1 and exactly 1 character. So at the Unix command line, we can use things that look like regular expressions, and for the most part they're the same, but that is one difference. We can give a range of characters by putting two numbers separated by a comma in curly brackets. That means M to N occurrences, and it is inclusive. So if I put 3, 6, that would mean I need 3, 4, 5, or 6 occurrences of whatever is in front of me. If you do M comma, it means at least M, but possibly more occurrences of the character. And if we put a single number in curly brackets, that is specifying exactly how many occurrences we would have. So that is a real brief introduction to regular expressions. And like I said, in the very near future, I'm going to come back and talk about using regular expressions in the Python programming language.